Okay, so here we have a good problem looking at tangents, circles, and all sorts of good stuff. So what we're going to do, we're going to start this off looking at this equation here. So an equation of a circle is stated, and they just want us to put it into this. Now we can see that we have two binomial squares. Binomial squares are factors of perfect square trinomials. So what we want to do is we want to complete the square. So I'm going to look at um, my x term, so I'm going to have x squared minus 6x. I'm going to leave a blank there. And I'm going to have the y squared plus 10y and another blank. And since this r squared is on the other side, it's going to be a constant. I'm going to move that 9 to the other side, so I have a constant over there. So now all I need to do is complete the square. It's nice and easy with these. Remember, we have to take this b value, divide by 2. So in this case, it's going to be -3, and square it. So we're going to be 9. Now, as this is an equation, if I add 9 to the left side, I have to add 9 to the right side as well. Here we have 10. 10 divided by 2 is 5. 5 squared is 25. And again, I'm going to add 25 to keep things nice and balanced. Well, we can group these with their x's and their y's. So we have x squared minus 6x plus 9. That's going to be x minus 3 squared plus y plus 5 quantity squared is equal to, well, these 9's cancel out, so we get 25. And that's exactly what they wanted for A. So this right here in just 2 quick steps gives us 3 marks. For B, they wanted us to write down the coordinates of C and also find the radius. With a question like this, there's no computation involved apart from part A. All it's basically asking you is, do you understand what this equation means? Remember, the equation of any circle, that's a horrible x. Yeah, that's a little bit better. X minus h squared plus y minus k squared is equal to r squared. Of course, here they have a and b. Same deal. This h and k, this a and b, that's the center of the circle. The center of the circle, if I'm using their a and b, it's going to be a comma b. So if it's x minus a, it's x minus 3. So the x value is 3. And if it's y minus b, this is really a y minus a -5. So the center is going to be at 3, -5. And the r value is going to be the square root of 25. Obviously, we're going to take the positive square root since it doesn't make sense to have a -5 radius. And that's all they wanted for part B. Okay, now for part C here, it starts to get a little bit more complicated. They ask us that part D prove that this is on the circle. So I'm going to get rid of all this, and we're going to start with part C. So part C, verify that this part D is on the circle. All we have to do is take the equation that we have. So again, this is x minus 3 squared plus y plus 5 squared is equal to 25. And we're just going to substitute in the 7 for x, so 7 minus 3 squared plus -2 plus 5 squared. If this works out, then this distance here is going to be 25. So 7 minus 3 is 4, 4 squared is 16, -2 plus 5 is 3, 3 squared is 9, and that equals 25 for sure. Important note here, for this part C1, you must have this to get full marks. So D lies on the circle. You need this. It actually states, it looks like an O, it actually states in the mark scheme that you must actually state that D lies on the circle. If you do not have this, you will lose the mark. All right, so for part C, find the equation of the normal to the circle at point D, giving your answer in the form here. So normal to the circle. if you think about what a normal is, it's just a perpendicular line. With a circle, that's more of an oval. With a circle, he said, and we have some sort of a tangent there. Tangent only touches at one point, so the normal, we want to go intersect this at 90 degrees. If I go through any point of the circle, you can see it's not going to go perfectly there. It's not going to be perpendicular to that tangent, so therefore it's not going to be normal to the circle. So actually what it must do is it must go through the center of the circle, and that's going to give us a line that's normal to the circle. Of course, if you already knew all that, then you know what we must do next. We first need to find the gradient. So, equation of a line, we need a point, we need a gradient at the very minimal. So what we're going to do, we're going to find a gradient, m, and we're going to find that to be -2 minus -5 over 7 minus 3. Gradient is change in y over the change of x. So here I have the y from d, which is -2, minus the y, which is the center of my circle. And I have the change in x, the denominator here, as the x value for the circle. Sorry, for the point D, which is on the circle, minus the x value for the center of the circle. So this is going to be -2 plus 5, which is 3, 7 minus 3, which is 4. Even though we're looking for a normal, we're not going to take the opposite reciprocal of this, only because this is what the equation is. Remember, this is the line that goes through this point and through the center. That, by default, is going to be normal to the circle, so I'm not going to change this gradient. Whereas in other problems, you might find a tangent line, and then you might take the opposite reciprocal to find the gradient. Here, we're not going to do that. All right, now what I'm going to do is I'm going to use this formula and rearrange it to get it to the form that they want. So this goes through the point 7, -2. So this is going to be y plus 2 is equal to 3/4 x minus 7. Clean this up a little bit. So y is equal to 3/4 x. This is going to be minus 21/4 plus 8/4. Oh, sorry, that's going to be a minus 8/4. Oops. Minus 8/4. So I'm going to have y is equal to 3/4 x minus 29/4. If you look here, they have coefficients for the x and the y. There are no denominators. It's nice that these have a common denominator, so what I'm going to do is I'm going to multiply each term by 4. So I'm going to get 4y is equal to 3x minus 29. And they want this to be mx plus ny. So we're just going to subtract, well, we can subtract the 4y from both sides and add 29 to both sides. That way the coefficient for x, this 3 is positive, and this other value, the constant, is also positive. So what we'd have there is we would have 3x minus 4y is equal to 29. So that's the answer for part C, number 2. M, n, and p are all integers. They are not fractions, as would have been the case with this. Okay. Of course, if I'm going too fast, that's the beauty of YouTube. You can pause it, rewind, and you can even leave a comment, and I will do my best to get back to you. All right, finally, part D. So a line has the equation y is equal to kx. We want to see that it has the same x coordinates, and it satisfies this equation. You gotta love it when they actually give you the answer. They're basically saying, here's the answer, find out what you have to do. And one key thing when looking at this is where did the i's go? Or sorry, where did the y's go? There are no more y's. In the equation here, we can see y's. Here the y's are replaced with k's. Well, what they do is they substitute. So if I have that original, so this is D, and we'll say part 1. If I have that original equation there, so x squared plus y squared minus 6x plus 10y plus 9 is equal to 0. And y is equal to kx, we're going to substitute. So x squared plus kx squared minus 6x plus 10 times kx plus 9 is equal to 0. And here, just like they have, I have no y's but only k's. So I can clean this up because this is one term with two factors. The index distributes, so I get k squared, x squared, minus 6x plus 10kx plus 9 is equal to 0. At this step, there's a lot of really cool, interesting things we can do with this. We can move this around, manipulate this, but we have to look at what they want. So the very first thing they have is this first term here, the k squared plus 1 in front of x squared. These first two terms both have an x squared. So actually, if we group these together, and then what we can do is group the next set together, then we're going to be left with this plus 9, and everything's going to be good. So here, if I factor out an x squared, I'll be left with 1 plus k squared, or let's make that look like they have it written. So k squared plus 1. Next I have a plus. I left this minus here, so really we could have made this a plus negative 6x. They both have an x, and they both have 6 and 10, so that's going to be a common factor of 2. Actually, I'm going to have one little micro step here where I'm going to rearrange this to be 10kx minus 6x, just so we can see the rearrangement maybe a little bit better. So they factor out the 2. We're left with 5k minus 3, and then they factor out the x and put it to the right rather than out front with the 2. And so that is the answer that they actually wanted. Yep, that's exactly what they wanted. So that is the complete solution there. Done. These nice steps will get you full 2 marks for that. Now they want us to find the values for k for which this equation, the one we just worked out, has equal roots. Okay, we're not going to be solving anything. Well, not really. I mean, we're not going to be going back to where we were. When your exam gives you a question like this, it actually gives it to you in it gives it to you so that it looks familiar, and this should look familiar. We have an x squared, we have an x, and we have a constant. That is a quadratic. Ax squared plus bx plus c is equal to 0. When you have a quadratic that has equal roots, it's going to be the discriminant, which is going to be equal to 0. So that's b squared minus 4ac is equal to 0. So b is the coefficient for the x value. So what we're going to do is we're going to have this full coefficient here. So 2 brackets 5k minus 3, and we're going to square that whole thing, minus 4 times a, which is the k squared plus 1, times c, which is the 9, and that should equal 0. So when I distribute this in, I'm just going to have 2 squared, which is 4. So 4, 5k minus 3, and that's going to be squared now, minus 36k k squared plus 1 will be equal to 0. Yeah, I guess I'll have to distribute this around and actually work this out a little bit more algebraically. So what I'll do is I will delete this, and we'll move this up just so we have some more space to work with here. So this is going to be a 4 brackets 25k squared minus 5 times 3 is 15, so this is minus 30k plus 9 minus 36k squared plus 1 is equal to 0. Distribute the 4, so that's 100k squared minus 120k plus 36 minus 36k squared plus 1 is equal to 0. Okay, so 64k squared minus 120k plus 37 is equal to 0. Oh, that's what I did. For a C, yes. I foolishly sort of messed this up a little bit. This shouldn't be a 1, obviously. This should be a minus 36. So for those of you watching at home who caught my little mistake there, awesome. Bonus points. I was testing you. So all these plus 1s are just going to be minus 36s. I was wondering where that constant was going to go. So here, plus 36 minus 36, they go away. So this is actually just these two equals 0. And we can factor this so that it is how could we factor this? I think they both have factors of 8. This is obviously not a calculator question, so I'm doing my best to not do this with a calculator. Is 120 factor of 8? It is. It's 15. All right, so we can divide everything by 8. So we're going to have 8k squared minus 15k is equal to 0. And then we are going to basically just solve for this. So we can factor this out. So we're going to have k brackets 8k minus 15 is equal to 0. Zero product property says that we're going to have two answers here. We're going to have k is equal to 0. And if we set this 8k minus 15 is equal to 0, that's an equals. We're going to solve that, and we're going to have k is equal to 15/8. So there's one answer, and there's the other one. So there are the two values for k that have equal roots. Oof, I almost got tripped up on that last part there, but I talked myself through it, and that's exactly what you should do. So stay calm, and you'll get it. The last part here described the geometric relationship between the line and the circle when k takes either of the values here. So when k takes either of these values, what's going to happen to the circle? So with this, if we look back here, And if you plug k back in, it's going to have equal roots. That just means that it's going to touch at one point. And so when a circle touches at one point, all we need to say that the line is a tangent to the circle. And that's a nice little one mark cherry on the top. Okay, that's pretty much it. So again, if you have any questions, feel free to drop a comment or get in touch with me. Happy math hunting.